Good?
Should be recorded.
All right. So this was your take-home quiz where you need to make sure you're paying attention to the directions because your test will have the same format. So you're supposed to write your given values, your working equation, some solution, and final answer. It would also be preferable for you to circle your final answer or box it, okay, or highlight it in some way. So for this particular problem, you're driving at 55 miles per hour, came to stop in 4 seconds. You're asked for two things, your acceleration and your displacement. And there are corresponding units for both. So if you look at your first unknown, meter per second squared, that is your derived quantities. It's a combination of several units, letting you know that you need to convert all your given values to units of meters for any length and units of seconds for any time. So the first thing that shows up there is your initial velocity, 55 miles per hour. You're going to do conversion with that to meters per second, and it's double conversion. So you've got your 1609 meters a mile, effectively cancels out miles, and then 1 hour over 3600 seconds effectively cancels out hours. And you'll look at this and you'll see the remaining units are going to be meters per second. Okay? So this is 24.6 meters per second. The other thing is you came to a stop, therefore your final velocity is 0, and that whole thing happened in 4 seconds. So if we link it to what we have learned in class, this is clearly an example of linear acceleration, right? Because there is a change in velocity. And so the first unknown is acceleration. It's a matter of definition for acceleration. Change in velocity over time. Substitute your values, and you end up with a negative acceleration here, which is consistent with the problem showing you it is decreasing in velocity. Okay? And the second part is looking for displacement, which is delta x. Well, the formula for displacement is the product of initial velocity and time added by 1/2 of the acceleration times time squared. You've got all of those values. It's direct substitution, and you end up with 49.2 meters. I'd like you to appreciate how long this is. We all have driven 55 miles per hour, right? And we had to stop really quickly. 4 seconds is not a long time. If you start now, that is 4 seconds, okay? So during that time, appreciate how much distance your car has moved. See this, 49.2 meters, roughly 50 meters. This is 1 meter. So you think about how much distance is needed to come to a full stop, okay? Sometimes you don't have enough distance, and so you'll have to do it much quicker. And you will know the effect on you as you slam on the brakes in, say, half the time. Half the time, this will be 2 seconds, and so you have less distance of stopping, which is good if you don't want to hit something, but will have consequences on the amount of force available as you stop. Okay? Any questions on this one? Did you all get the correct answer? Right? So good? All right. Second question. You have a rock dropped from a bridge. Takes 2.5 seconds to hit the stream below. You're asked for two things, the height of the bridge and also the impact speed. So I like to sketch this. Your initial velocity is 0 because it's dropped. And it hits the ground 2.5 seconds later. Question?
Yeah, shouldn't those all be two significant figures?
We're not going to follow significant figure rules. Unless, remember I did say at the beginning, unless it's indicated in the problem. Okay?
So you take off points if we did?
No, we don't. We don't. Okay, so for number 2, this is clearly acceleration along the vertical axis. And one equation that already will allow you to solve for displacement is delta y is initial velocity times time plus 1/2 gt squared, where your initial velocity is 0, so this whole term disappears here. So your working equation is clearly just delta y is 1/2 gt squared. Your acceleration is gravitational acceleration. So plug in your values, remembering to put a negative sign here to indicate it is a negative direction, and remembering to square your time. You will end up with a negative displacement, which is correct because at the end of the motion, your object is below the starting point, below the starting point. But since you're being asked for a scalar quantity, which is height, you take the absolute value of that. This will be your answer. Okay? For the second part, you're asked for how fast, what's the impact speed. And clearly it's not 0, just before impact. So your final velocity is equivalent to your initial velocity plus the product of gravitational acceleration times time. So again, this one is 0, and substituting the time of 2.5 seconds, you end up with a negative velocity. Again, negative indicating it is downwards. Questions on this one? Okay? All right. Moving on to number 3. And this is going to be seen in so many problems on your test. Okay? I'm going to give you a heads up already. So many problems on the test will be about vector addition. Okay? So you've got your problem telling you you walked for 5 miles northeast, then turned and walked another 10 miles at 30 degrees north of east, and then lastly 4 miles at 20 degrees east of south. So the way that I recommend you do this, these are all displacement vectors. You can represent them as D, with an arrow at the top, or you can just use capital letters to indicate displacements, A, B, and C. You're asked for resultant displacement, which is R over here, and it's just the sum of your individual vectors. Okay? So the next step will be identify the angle theta. What we need to remember is to have a consistent equation for x component and y component. We want to identify the angle theta, which the vector makes with respect to the x-axis. I hope that's clear, with respect to the x-axis.
We always use with respect to x. That's why we have 70, right?
Yes, we're always using the x-axis for our generic equation. If, however, you would prefer to use the other angle, then just make sure you're using the correct function. Okay? So, northeast, anytime you have a combination of 2 geographical directions, that's an angle of 45 degrees. Okay? Here, it's 30 degrees north of east. So if this is your x-axis, and this happens to be the vertical or y-axis, all right? North of east is in this quadrant. And north of east particularly says north from east. So it is right here, 30 degrees. North from east. And that happens to be the angle with the x-axis. All right? For the third angle, for the third vector, you've got 20 degrees east of south. Well, east of south, this is east. South is below, right? East of south is you're measuring from the south going to east. So it's actually 20 degrees with vertical. So our angle theta is 70 degrees. Okay? This is very crucial. Because remember that in class, we did say the x component of each vector is plus or minus a cosine of the angle theta. Alright? Because all of these x components will be adjacent to an angle theta with respect to the x-axis. So simply substitute vector, cosine of the angle. Vector, cosine of the angle, and so on. You use your calculator and you're using the 20-degree angle, the x component will be 4 miles sine of 20 degrees. Okay? Sine of 20 degrees is equivalent to cosine of 70 degrees. Right? And so write down your values over here and then pay attention to where the quadrant is, where the vector is located. Northeast is first quadrant. That's got to be x, positive x component, positive x component, east, positive x component. All right? You'll do the same thing with the y component. So it's going to be a sine of the angle. So just directly substitute, write down your values, and realize that this one is north, this one's north, so those are positive y components, but this one is south. So this is going to be a negative component. All right? Your next step is sum up your x components of your resultant. You end up with positive 13.6 miles. Do the same thing with all your y components. So this is simply component method. We resolve the vectors into their components. So we'll eventually end up with a total of all x components a total of all y components. And since these are perpendicular to each other, as shown over here, positive x is here, positive y is up there, we have learned that to get the resultant of two perpendicular vectors, you simply get the diagonal using Pythagorean theorem. So Pythagorean theorem is the sum of the squares, right? The square root of the sum of the squares is 13.6 miles quantity squared added by 4.7 miles quantity squared. Notice here it doesn't matter whether these are negative inside, because when you square it, it will disappear. So you take the square root of the two sums, you get 14.4 miles. All right? And then to figure out this is your magnitude, the size of your displacement vector. The direction is the angle theta. Notice it's with respect to the x-axis again. If you look at your diagram, you have an adjacent side and an opposite side right here, opposite. So the two sides plus the angle are related by the tangent function. If you want to solve for theta, it is the inverse tangent of opposite side over adjacent side. Okay? And it is positive 19.1 degrees. So to refresh your memory, your angles are going to be positive if this is your x-axis, if you're measuring counterclockwise from x. And it's going to be a negative angle if you're measuring clockwise from x. Questions? Let me stop that for a bit and then we'll move on to the next one. All right.